I am doing well. Just getting ready to go up to Green Bay for ACT testing tomorrow. I'm trying to get all my stuff all ready. All right. Oh, sorry, my printer is printing off my reimbursement form. All right, I take that back. It's printing everything I haven't printed or hasn't printed in a while. Okay, let's get going. Week number 7. This should be an easy week for you. Let's do some reviewing. This week we're going to be talking about slope fields. Slope fields are pretty easy, but before we do any slope fields, let's talk about what we were doing last week, and that is using substitution to find the integrals of different functions. Okay, so if I was going to do this problem, let's get a writing tablet out here. It already tells me what u is going to equal in this problem, so I'm obviously going to use their suggestion because it's usually right. So in this problem, I would say that u is equal to 6x. So du dx is equal to 6. And then I want to rewrite it so it's dx equals something. So du over 6 equals dx. So now I'm going to substitute this where I see u and this where I see dx. So it's going to end up being the integral of the sine of u and then du over 6. Now I'm going to bring that 6 out in front. So I'm going to rewrite it as 1/6 integral sine of u. Well, the integral of the sine, now remember, the derivative of cosine, or the derivative of sine is cosine. So the integral of sine, isn't that, I always have to write this down. So sine, cosine, negative sine, negative cosine. So it's going to be negative cosine. So this is going to be 1/6, I'm going to put a negative in front, cosine of u. And then I have to place my u back in there. So my answer should be -1 cosine 6x over 6. And that is my integral. And don't forget to always put the u value back in. All right, I'd like you to try one now. How about this one here? I've got 5 times 5x plus 1 to the -2nd, and they tell us that u is equal to 5x plus 1. So what is the integral for that? -1 over u. Now, I know that can't be right because you shouldn't have a u in your answer. Your answer should have x in it. So if you ended up with -1 over u, then I'm assuming your answer would be -1 over 5x plus 1. Okay. And I think you did that on one of the problems on the assessment. You forgot to plug it back in. So in this problem, if I was going to work this out, I've got the integral of 5 and then 5x plus 1 to the negative second power. They tell me u is equal to 5x plus 1. So if I take the derivative, du over dx equals 5. So du over 5 is equal to dx. So I'm going to substitute, so that gives me 5 u to the negative second, and then I'm going to put that 5 in there, so that's du over 5. Well, those 5's just cross off, which is nice. So if I take the integral of this, we add 1, so that's u to the negative 1. And then I just plug it back in, so that's 1 over u, which is 1 over 5x plus 1. 5x plus 1. I'm not sure I get a negative there, though. Where did you get the negative 1? I end up with, oh, yeah, yes, it is. You are absolutely correct, because when you take the integral of u to the negative second, you end up with u to the negative 1 over negative 1. You are absolutely right. Yes. So that there should be a negative there. Okay. Very good. Awesome. And they get, I mean, a lot of times they don't, well, most of the times they don't tell you what the u value is. So in this problem, I know my u value has to be t to the third, because when I take the derivative of that, I get 3t squared, which is going to cross this off. So I would do u is equal to t to the third plus 4. Du over dx is equal to 3t squared. And then I end up with du over 3t squared dx. Now I substitute. So I've got the integral of 3t squared, and then u to the fifth times du over 3t squared. Those are going to cross off. So now all I have to take the integral of u to the fifth, which is u to the sixth over 6. So my answer is going to be t to the third plus 4 to the sixth power over 6. So that is a quick review of last week's material, just taking integrals using the substitution method. Now this week, we're going to be talking about slope fields. Slope fields are pretty easy. Next week, we're going to be talking about differential equations using the slope fields. And I should have, most years I would do this at the same time, but with the ACT testing this week, along with no school on Friday, I kind of figured to split it up. So we're going to do slope fields today, and then we're going to do separation of variables next week. Separation of variables is much harder. And then the following week is spring break. Whoop, whoop. You gotta love that. Okay, so slope fields. Yes, exactly. If you are going to try, and this is the whole concept, the differential equations gives the slope at any point xy. This information can be used to draw a small piece of the linearization at the point which approximates the solution curve that passes through the point. Repeating that process at many points yields an approximation called a slope field. Now, in English, what does that mean? If I gave you a problem like y is equal to, and this is just my equation. So let's say we had f of x equals x squared. We know the derivative of this is 2x. So tonight, what they're going to be doing is they're going to be giving us just a derivative. Okay, so this is the derivative right here. They're going to give us a derivative, and they're going to ask us to make a slope field. I'm going to do this at many more points here. And what you do when you're doing a slope field, and they'll give you a graph, and they'll give you all these little points on there, and then what you have to do is you have to find the slope at every given point. I'm not going to do this one, or this one, because we have enough points here. So this is -2, this is +2. So what are all these values? Well, -2, 0. This point here is -2, 1. This point here is -2, 2. Then I go to this point. Well, that's -1, 0. And then I'm going to go up. So that's -1, 2. And then -1, 1. And then -1, 2. then I'm going to go to this point, and I'm just going to set 0, 0, 0, 1, 0, 2. And let me tell you, sometimes you'll get this many points and you'll get more. So then I'm going to go over to this side and do these. So that's 1, 0, 1, 1, 1, 2. And then these points here are 2, 0, 2, 1, and 2, 2. So the first thing you want to do is you just want to write down all the points that you have to find the slope for. And then what you're going to do is you're going to find the slope. So if this is my x value, this is my y value. So if I plug it into the derivative, because what does a derivative give us? It gives us a point or the slope at any given point, right? So what would the slope be at negative 2, 0 if this is my derivative? And all you're going to do is you're just going to plug in the value. Okay, so put negative 2 in, so it gives me negative 4. And then if I go negative 2, 1, guess what? That's negative 4. And this is negative 4. And you'll see there'll be a pattern most of the times when you're doing these slope fields. And then here, if I put negative 1, 0 in there, it's going to be negative 2, negative 2, negative 2. If I put 0 in there, it's going to be 0, 0, 0. And this is exactly what you want to do, is you want to find the slope. So this is going to be 2, 2, 2. And this is going to be 4, 4, 4. Okay, so far so good. All I did is I put the ordered pairs down, and then I found the slope at each given point. So far so good. Okay, then the next step is to draw a very small slope at each given point. So at negative 1, 0, I'm sorry, this is negative 2, 0, way over here. The slope is negative 4, so that might look like this. Negative 4, negative 4 slope, negative 4 slope. So here at negative 1, it's negative 2 slope. So that doesn't go down as quickly. So negative 2 slope would look something like this. At 0, 1, and 2, it's 0 slope. 0, 0 slope, 0 slope. At 1, I've got positive 2 slope. At 2, my slope is 4. So take a look at this slope field. This is called a slope field. And if you draw in a line using your slope, oops, I should be way over here. It will look like the original function that we had. And what was the original function? What is the original function for the derivative of 2x? Isn't it x squared? So doesn't my slope field look like a parabola? And that is called a slope field. The more points you make, the better the design is going to look like what you're dealing with. But what a slope field does is it gives you a representation of what this is my derivative. Now, this is a really easy one. Usually they're going to give you something like this. They'll give you dx dy is equal to like, maybe 2x minus y. So then you're going to have to use both values, the x and the y, to come up with each slope. Okay? But the concept is fairly easy. It's just, you're just going to make tiny little lines, and then you're going to try to see if you can see what the original graph looks like. Now, next week, we're going to be given something like this, and we're going to have to come up with the original equation. And this is what is called separation of variables. We have to separate, we have to get the x's on one side, the y's on one side, the dx on one side, the dy on one side. It's a whole lot more complicated. But the slope field part is fairly easy. You just take your points, you find your slopes, you graph it out, boom, you're done. That's it. That's all we're dealing with this week. Next week, separation of variables. Oh, definitely a little bit harder. Okay, so in this problem, how many points do I have? I have 3, 6, 9, 12. I have 12 points. This is a problem off an AP test. They give you this sheet, they give you this point. Now, they'll ask you like 3 different things off there, but the first thing always is find the slope field. Okay, in order to find the slope field, what I suggest is just write down all the values. So in this problem, I've got -1, -1. I've got -1, 0. negative 1, 1, negative 1, 2. Then I have 0, negative 1, 0, 0, 0, 1, 0, 2. Then I have 1, negative 1, 1, 0, 1, 1, 1, 2. Okay, whew, got all my points. Now I have to find the slope at each given point. Okay, well, this one's a little bit tougher because the last one we only had one variable to plug in, right? This one I have to plug in both. So if I put negative 1 in here, that gives me negative 2 minus 1. It's negative 3. If I put negative 1, 0, that gives me negative 2. If I put negative 1, 1 in here, that's negative 2 plus 1, that's negative 1. And negative 1, 2 would be 0. And then I go to the zeros, 0, negative 1. So if I put 0 in for this, this is just going to be 0, right? So this is just going to be negative 1, 0, 1, 2, because that value is going to go away. So now this one's going to be 2 minus 1, which is 1, 2 minus 0, which is 2, 2 plus 1, which is 3, 2 plus 2, which is 4. So now I have all of my slope. So the next step would be just to draw in those slopes. So negative 1, so that's negative 3. So negative 3 might look something like this. Negative 1, so that's negative 2, so it has less slope. Then I have negative 1, and then I have 0. Okay, and then again, then I just go back here. So 0, negative 1, that's negative 1 slope. 0, 0, 0 slope. 0, 1, 1 slope. 0, 2, 2 slope. And then here I've got, what is that, 0, 1, negative 1, so that's 1 slope. We'll go a little bit less. 2 slope, 3 slope, 4 slope. And that is all they expect you to do. But they do want you to show your work here. So that's, and you don't have to draw anything in. You just leave it like that. That is called a slope field. Now, let's try one that you would see on a AP test. This is a problem off an AP test. I'm not sure what year it is, but I would like you to do part A and part B. Okay. Let's see here. Find the particular solution. Nope, you can't do part B because that is a separation of variables problem. Wait, can we find the particular solution to the differential equation? To the differential 0. Can we do that? I think we can. Yes, you should be able to find the answer to that. Okay. Now, this is really tough because there's no way I can tell. You're not going to be able to draw this out unless you want to work on the board. I don't know if you're comfortable working on the board there. But let's so I'll do, because obviously if you do the work on the outside, you can't show me your answer because it is a slope field. So let me just put the points down and then you can tell me what the slopes are for them. Okay, so we have negative 1, 0. We have negative 1, 1. We have negative 1, 2. They don't ask us to find any values here because it's not solid. So here we have 1, 0, 1, 1, 1, 2. And then we have 2, 0, 2, 1, 2, 2. Okay, so what is it? Oh, where did my points go? Huh. There we are. Okay, so at negative 1, 0, what would the slope be? Negative 1. Okay, so negative 1, yep, that is correct. How about at negative 1, 1? It would be 0. Negative 1, 2. I'm doing these faster than I can do them in my head. Okay, so that would be 1. That is correct. 1, 0. Negative 1. Yep. 1, 1. 1, 2. Correct. 2, 0. Negative 1/4. 2, 1. 0. Anytime there's a 1, it's going to be 0, right? And 2, 2. 1/4. Okay. Now, the next step, we're just going to put the slopes in there. So negative 1, 0, negative 1 slope. Okay. Negative 1, 1, 0 slope. Then 1 slope. Then we have negative 1 slope again. Oops. 0 slope, 1 slope. And then we have negative 1/4. So negative 1/4 is almost. And then 0. And then 1/4. And there's my slope field. That's it. Now, part B. And then usually part C will be to ask you to use separation of variables to find the original equation. So that's what we're going to do next week. Next week, here's a preview of next week. dy dx is equal to y minus 1 over x squared. Next week, we have to get the dx on one side and the y's on one side. So I could rewrite this as dy over y minus 1 is equal to dx over x squared. And then the next step would be to take the integral of both sides. As I said, it gets a little bit complicated next week, but that's our first 2 steps. Is we have to get the y's on one side, we have to get the dx's on one side, and then we're going to take the derivative or the integral of both sides, and that's where it gets a little complicated. But we'll get that next week. All right, so let's go to part B. Part B, it says find a particular solution, y is equal to f of x, to the differential equation with the initial condition f of 2 equals 0. Okay, well, to find an equation or to find a particular solution, we need an equation, right? And what I can do, and this is not a separation of variables problem, but I know that I have a point, right? They gave me a point, 2, 0. I know I have slope at that point. At 2, 0, the slope is 1/4. Negative 1/4, isn't it? Negative 1/4. So I could write an equation. I could go y minus 0 is equal to negative 1/4 x minus 2. And that is all we'd have to do for that problem. But don't worry about that. Next week, it'll get a little bit easier when we start finding separation of variables. Okay. And here's the slope field that was for our thing. Okay, it looks pretty close. So here is another problem. I don't want you can't do C yet because that's separation of variables. So what I want you to, no, again, you really can't do anything this week. That's the weird part, is because you can't show any work. Okay, so again, this is another problem off an AP test. You can tell because it says use the axis provided in the test booklet. So this would be in the test booklet, and then your work would just be, so let's cross this one out. But I do want to do the next one. Okay, so in this one, again, the first thing that you're going to do is you're going to find the points. So I've got negative 1, 0, negative 1, 1, negative 1, 2, and then we've got 0, 0, 0, 1, 0, 2, and then we have 1, 0, 1, 1, oops, 1, 2, and then we have 2, 0, 2, 1, and 2, 2. All right, again, kind of a crazy looking thing here. All right, but I'm just going to put negative 1 in for x and 0, 1 for y. So what is -1, 0? Is that just 0 then? So if the x or the y is 0, I know the answer has to be 0, right? So I can do a bunch of these right away. Right? Because if you have x or y equals 0, the whole top is going to be 0. I might as well just put those easy ones in there. And then how about -1, 1? What would that be? 1/2? Agreed. How about -1, 2? 4/2 or just 2? Now we know all of these are zeros. So let's go down to, is that 1, 1? What would my answer be for 1, 1? -1/2. How about 1, 2? -2 is correct. How about 2, 1? -1. And how about 2, 2? -4. Good. Yep. And that's as easy as it gets. And then you just, okay, so I've got 0 slope here, 1/2 slope here, 2 slope here. And then I've got 0, 0, 0, and then 0 here, -1/2, which is over here, -2. Then we've got 0 again, -1, and +4. So there's my slope field, and that's all they're going to be asking. Now, the part B, it says write an equation for the tangent, for the line tangent to the graph, and I think this is what I was trying to get at in the last problem. Write an equation for the line tangent to the graph of f at x equals -1. Well, up here, it told us at -1, 2. So they gave us, in the beginning of the problem, they gave us the point. The point is -1, 2. And then I just need the slope. Well, guess what? All I have to do is go to -1, 2. The slope is 2 there. So now if I want to write an equation of a tangent line, just y minus 2 is equal to 2x plus 1. And there's my tangent line. That is basically it for this week. I mean, I could do some more problems like this, but it's all the same. You're just taking the points that are given and you're finding the slope. And then you're just drawing a tiny little line with that slope in there. Any questions on that? As I said, next week, a whole lot harder. All right, so that is it for this week. I will go in and open up the assessment for you so you can get working, but that's all we're going to deal with this week. And then next week, we're going to deal with separation of variables, which takes it way harder. All right. You have a great one too. Bye.